This question is about the halogen group of elements and some of their compounds. Part A. The halogens show trends in their properties down the group. The boiling points of 3 halogens are shown below. Explain why halogens show this trend in boiling points. For any question where you're asked to describe a trend, you need to specify which direction. So we're going to go down the group. What happens down the group is that London forces of attraction increase. They're sometimes referred to as van der Waals forces, but London forces is accepted here. And it's because the number of electrons increases. So this is your second statement you need to write for this question. And then you need to link to why the trend in boiling points, and that's because if there's more London forces of attraction or they're increasing, more energy is needed to break the London forces of attraction. Again, saying London forces, not van der Waals, because of the specification we're on. To get your 3 marks for this question, you get your first mark for saying that London forces increase, your second mark for saying that electrons increase, and your third mark for saying that more energy is needed to break the London forces of attraction, or London forces. Part B. Hydrogen iodide, Hi, is decomposed by heat into its elements. The decomposition is much faster in the presence of a platinum catalyst. Complete the enthalpy profile diagram for this reaction using formulae for the reactants and products. Use Ea to label the activation energy without a catalyst. Use Ec to label the activation energy with a catalyst. And use delta H to label the enthalpy change of the reaction. The first thing we need to notice about this question is that we have a positive enthalpy change of reaction. That means that the reaction is endothermic, so that will impact the shape of our enthalpy profile diagram. The shape will be that we have our reactants on the bottom, so 2Hi gas, and our products at the top, H2 gas plus I2 gas. Then we're going to have 2 different enthalpy profile diagrams effectively, with 2 different activation energies labelled. We'll have one which is slightly higher and one which is slightly lower. Then labelling our activation energies with and without catalysts. The slightly higher enthalpy profile diagram will be our activation energy without a catalyst, and our slightly lower enthalpy profile diagram will be our activation energy with a catalyst. Finally, we need to label the enthalpy change of reaction, and it's a positive value, so we're going to go from our reactants to products upwards because enthalpy is increasing, and we'll label it delta H. To get the 3 marks for this question, you get your first mark for having your reactants and products on the right sides of the correct sides of the progression of reaction. So having your reactants on the left and products on the right. You get 1 mark for having the correct enthalpy change of reaction arrow, and then you get your third mark for having the correct activation energy with and without a catalyst. Part C. Compound A is an oxide of chlorine that is a liquid at room temperature and pressure and has a boiling point of 83 degrees. When 0.4485 grams of A is heated to 100 degrees Celsius at 1.00 times 10 to the 5 pascals, 76.0 centimeters cubed of gas is produced. Determine the molecular formula of compound A. Show all your working. Let's begin this question by highlighting key pieces of information we're going to use. Firstly, the mass of A, and then the temperature, pressure, and volume amounts we have been given in this question, because we're going to use the equation PV equals nRT. So we're going to be using something called a list method, and this helps us to understand what we have in the question and what we need to find out. So P stands for pressure. We have our pressure is 1 times 10 to the 5 pascals. Volume, we've been given also 76 times 10 to the negative 6 meters cubed, because we're converting units from centimeters cubed into meters cubed for this ideal gas equation. Number of moles, we don't know, so we can leave a question mark because we're going to figure this out. R, we get given in our data sheet, is 8.314. And T stands for temperature, so it'll be 100 degrees Celsius plus 273 equals 373 Kelvin, because we're converting degrees Celsius into Kelvin for this equation. So then working out number of moles and rearranging the equation, we need to do PV, or 1 times 10 to the 5, times 76 times 10 to the negative 6, divided by RT, or 8.314 times 373. That gives us a number of moles value of 2.45 times 10 to the negative 3 moles. Then we're going to be using another equation. Mass over number of moles equals relative formula mass. So, working out our relative formula mass, we've been given our mass is 0.4485, dividing by our number of moles, 2.45 times 10 to the negative 3, gives us a relative formula mass of 183. And because we're told in the question it's an oxide of chlorine, that means that our relative formula mass is going to consist of chlorine and oxygen, and we can extrapolate the molecular formula of Cl2O7. This is because the relative formula masses of Cl2O7, so 35.5 times 2, which is Cl2, plus 16 times 7, which is O7, equals 183. So the relative formula masses match, and therefore our answer is correct. To get the 4 marks for this question, you get your first mark for using the lists method and converting all units into the correct units for this equation. So centimeters cubed into meters cubed, degrees Celsius into Kelvin. You get your second mark for correctly working out the number of moles, or 2.45 times 10 to the negative 3. You get your third mark for working out the relative formula mass, or 183. And your fourth mark for correctly determining the molecular formula of A, or Cl2O7. Part D. Compound B is an iodate 5 salt of a group 1 metal. The iodate 5 ion has the formula IO3-. A student carries out a titration to find the formula of compound B. Step 1. A student dissolves 1.55 grams of B in water and makes up the solution to 250.0 centimeters cubed in a volumetric flask. Step 2. The student pipettes 25.00 centimeters cubed of the solution of B into a conical flask, followed by 10 centimeters cubed of dilute sulfuric acid and an excess of Ki aqueous. The iodate 5 ions are reduced to iodine, as shown below. Step 3. The resulting mixture is titrated with 0.150 moles per decimeter cubed Na2S2O3 aqueous. The student repeats step 2 and step 3 until concordant titers are obtained. Part 1. Complete table 20.1 and calculate the mean titer that the student should use for analysing the results. For this question, we need to complete table 20.1. To work out the titers which are missing from table 20.1, we need to do the final burette reading minus the initial burette reading. So for the trial, that would be 24.00. We need to give all of our titer readings to 2 decimal places. For titration 1, that's 23.40. For titration 2, 23.75. And for titration 3, 23.85. Then we're asked to find the mean titer. In order for the mean titer to be found, we need to use concordant titers. Concordant titers are within, or plus minus, 0.10 centimeters cubed of each other. So the concordant titers in this question are from titration 2 and titration 3. So working out the mean titer would be 23.75 plus 23.85. Dividing this by 2 gives us a mean titer value of 23.80. Again, giving our answer to 2 decimal places, writing this on the answer line. To get the 2 marks for this question, you get your first mark for correctly completing table 20.1 and your second mark for identifying the concordant results and determining the mean titer, 23.80 centimeters cubed. Part 2. The uncertainty in each burette reading is plus minus 0.05 centimeters cubed. Calculate the percentage uncertainty in the titer obtained from titration 1. Give your answer to 2 decimal places. When working out percentage uncertainty, we take the uncertainty of the equipment, so 0.05, multiply it by the amount of times we've used this equipment, in this case twice, to work out the titer for titration 1. So this would be 0.05 times by 2 divided by 23.40. Then multiply by 100 in order to work out percentage uncertainty. That gives us an answer of 0.43%. That is our answer to 2 decimal places, which we will write on the answer line. To get the mark for this question, you need to have the correct percentage uncertainty, 0.43%. Part 3. Describe and explain how the student should determine the endpoint of this titration accurately. The first point we need to make in this question is that we're going to add an indicator. We're going to add starch as our indicator for this titration. Next, we need to state the colour change starch is going to make to determine the endpoint of this titration. The colour change is going to be from a blue or black colour to colourless or clear. To get the 2 marks for this question, you get your first mark for saying to add starch and your second mark for saying the colour change will be from blue to colourless. Part 4. Determine the relative formula mass and formula of the Group 1 iodate 5B. Show your working. So what I've done firstly is copy across the information from table 20.1 and our calculated mean titer. Next, we need to highlight other key pieces of information in the question. The mass of B the student is using is a key piece of information, alongside the volume the student is making the solution up to, 250 centimeters cubed. But the student's using 25 centimeter cubed samples, so there's a factor of 10 we need to account for later on in the question. Then our next key piece of information is the concentration of Na2S2O3 we've been given as 0.15 moles per decimeter cubed. And then thirdly, our mean titer that we have calculated is our next key piece of information in this question, because we're going to be using the equation triangle NV times C. So using this equation triangle, we can work out the number of moles of S2O3 2-. That would be taking volume and multiplying it by concentration. We're given the concentration in the question, 0.15, and we've worked out the volume is 23.8 times 10 to the negative 3 because we're converting centimetres cubed into decimeters cubed. That gives us an answer of 3.57 times 10 to the negative 3 moles. Then we need to work out the number of moles of IO3-. We do this using the 2 equations we're given in the question. So firstly, we need to look at similarities between the 2 questions. Well, we know the moles of S2O3 2-, so we can work out the number of moles of I2. The number of moles of I2 would be half the number of moles of S2O3 2-. And in the first equation, where we're given IO3-, they are 3 times the number of moles of IO3-. So, working backwards, that means that the number of moles of S2O3 2- are 6 times the number of moles of IO3-. So to work out the number of moles of IO3-, we take 3.57 times 10 to the negative 3 and divide it by 6. That gives us a number of moles of 5.95 times 10 to the negative 4 moles. Now we need to account for our times 10, or factor of 10. And that is because the number of moles we've just calculated is the number of moles in 25 centimetres cubed. And we've made the solution up to 250 centimetres cubed. So we need to take the number of moles, 5.95 times 10 to the negative 4, and multiply this by 10, which gives us 5.95 times 10 to the negative 3 moles. Next, we need to work out the relative formula mass of the group 1 metal, and that would be using the equation mass over moles equals relative formula mass. We've been given the mass in the question, 1.55. We've just calculated the number of moles, so 5.95 times 10 to the negative 3 gives us a relative formula mass of 260.5. So we can write this for the relative formula mass of B that we calculate. And then the formula of B, well, we need to match the relative formula mass to the mass of a group 1 metal. So to find the group 1 metal, we can take the relative formula mass, 260.5, and subtract the relative formula mass of the iodate 5 ion. So that would be 126.9 plus 16 times 3 gives us the relative formula mass of the group 1 metal is 85.6. Matching this to the closest group 1 metal, that is rubidium. So the formula of B would be RbIO3. To get the 5 marks for this question, you get your first mark for working out the moles of S2O32- correctly, your second mark for working out the number of moles of IO3- correctly, your third mark for working out the number of moles of IO3- in the 250 centimetre cube solution, so multiplying by 10. Your fourth mark comes from working out the relative formula mass of B, so 260.5. And then your fifth mark is working out the relative formula mass of the group 1 metal and then determining that this is rubidium, and then writing the correct formula of B. That's your fifth mark.